Thank you.
Currently somewhere in the middle of Norfolk. I think it's Thetford, I'm pretty sure, because I picked something up, a little bit of a synthesizer. Let's have a look. It's really interesting. How's it going? Today we're going to be talking about this synthesizer, the Titan synthesizer that was built by a lovely person called John. I drove up to Norwich nearly a year ago now to go and pick up this synthesizer. It was just before I embarked on the church organ project. And since picking it up, I haven't managed to make a video on it yet. And there's a number of reasons, and we'll touch on those in this video. But the reason why now is a great time to talk about this synthesizer is because it is a DIY magazine synthesizer, much like the Practical Electronics PE synthesizer that we touched on a couple of weeks ago. Of course, these aren't the only DIY project synthesizers we have covered. There is a playlist and it is linked below with a bunch of videos of different DIY synthesizers of the era and how quaint and interesting they are compared to their manufactured counterparts. However, this synthesizer shares a lot more in common with the Practical Electronics PE synthesizer that we just touched on than any of the other DIY synthesizers in this series. Because this project was published in exactly the same year as the Practical Electronics PE synthesizer. This is based on the project called the Electronic Sound Synthesizer, authored by D.W. Thomas and Tim Orr, and it was published beginning in August 1973 in Wireless World. Remember that the Practical Electronics PE synthesizer began in February 1973, and this series spanned over a year of magazines. The Wireless World Electronic Sound Synthesizer was over and done with a full synthesizer by the end of October 1973. So the Practical Electronics PE synthesizer was nearly 12 issues, and this one was only 3 issues. And the Electronic Sound Synthesizer being only 3 issues long might have been reactionary to the fact that the Practical Electronics synthesizer managed to come out a few months before. And as the months trot along from August to September to October, the issues get more and more packed with information and modules. Anyway, we'll be looking at this in more detail in a little bit. First, let's rewind back to when we picked this up from John. When did you start making this?
I started in 1973 when I got this Wireless World article. It was just a chap in Southampton University, I think.
Tim Orr, yeah.
This is all the sort of info I had, just circuit schematics. So I had to then make the boards up from scratch. And
so I saw, yeah, in the comment you said you hand drew the circuit boards.
The original power supply board, I've changed that recently. This is on Paxilin, but all the rest are on fiberglass boards. That was mains in via a transformer, and then into here, plus and minus 15 volts and 5 volts out.
Yeah. Oh, so this needs 5 volts as well, does it?
Yes, 5 volts plus and minus 15.
Where were the potentiometers from?
Yeah, they came from a chap in Burr Street, Norwich. Mick Helps, his name. He had a sort of a surplus store when I was at Tech, and that's where we used to go sort of in lunch times when we were at Technical College in Norwich. He had all these sort of bits and bobs, you know, and so we just made up a...
So you said you didn't finish it until recently, is this correct?
Yeah, well, I hadn't made the filter and the white noise generator. And then I changed all the electrodes, the old electrolytic capacitors, because they were sort of getting on.
It's a serious job when you have to change the capacitors halfway through the project, as it's gone.
Yeah, that's right. Yeah, it's gone on so long.
These long switches.
Yeah,
it's amazing. I haven't seen those.
Right, yeah. Plus and minus 15 volt rail there. Yeah, main power switch. Yeah.
Wow. Where did you get? Was that?
I can't remember where that came from, to be honest. I must have bought it at one of these Wireless World.
Incredibly cool.
That does.
Oh, is this steps? Six steps.
Yeah. You can set each step to whichever amplitude you want.
So after getting it back, of course, it was quite exciting. It was a new synthesizer project to explore. I first did a Patreon live stream, and I've just found it again. And here's a couple of snips of it making some funky noises. So if you look, like he's used Letraset for the writing, and he sprayed over it, and now over time it's got a weird, like, the lacquer's kind of like bumped up. It looks quite nice. Looks like a really old aircraft dashboard. Is it a dashboard? So I guess we're just going to plug it in. After this, it all unfortunately went a little bit downhill. First off, I already had a copy of the issues of Wireless World that included this project. Of course, there are scans uploaded of these online. There's a link below if you're interested for an amazing repository of a heck of a lot of old electronic magazines. But typically, a couple of days after getting this, I decided to go somewhere to have a read of the magazines just to get a little bit more up to date on the actual project before I did a video. And an older fellow with a Zimmer frame was struggling to get across the road. I helped him across and I put them in the Zimmer frame pocket. It turned into a little bit of an ordeal that ended up being about an hour of trying to get him home. And I totally forgot that I left the Wireless World magazines in the Zimmer frame. I didn't see the last part of his journey because somebody recognised him and picked him up. So I don't know where the heck he lived. So the next time you help somebody with a Zimmer frame across the road and you have your Wireless World copies, remember to take them out of the Zimmer frame when you've finished. I also took the synthesizer over to This Museum Is Not Obsolete to display it. And unfortunately, a couple of hours after it being on, it started to become a smoke machine. Sadly, the newest power supply wasn't up to the task, which caused the rectifier to go up in smoke. This also, coupled with picking up the church organ a couple of days after, this ended up getting put into the cupboard to pick up another time. And the other time is now. It's now. But first, before we dig into the Titan synthesizer, let's have a rundown of the actual magazine project itself. This journey starts with the August 1973 issue of Wireless World. It's really fun inside Wireless World. Let's open up the cover. Wireless World. That was a theme tune that's been stuck in my head whenever I've been reading it. Anyway, going past this Telequipment sponsored ad, you will get into the first part of the electronic sound synthesizer, which is Timur's debut into magazine issue synthesizers. You have a look at the built prototype and also the patch bay and how it relates to the rest of the planned modules which you will hopefully be building. The first part mainly focuses on the oscillators, the VCO1 and VCO2. They're both linear oscillators and you can have a look at the circuit, and also there's this interesting triangle to sine wave converter that's made of a diode ladder. These are the knobs on the front. You'll notice that the labels are slightly different to modern ones, including bias and mark space, which is the pulse width, and yeah, you also get a ramp function generator, which is a low frequency oscillator. Stop right there, I made a bit of a boo-boo. The ramp function generator isn't a low frequency oscillator at all. In fact, there is no dedicated low frequency oscillators in this synthesizer. There's a VCO1, VCO2 and VCO3. August looks at VCO1 and 2, which are largely the same, but interestingly enough, they are both slightly different. For instance, the actual core of voltage controlled oscillator 1 and voltage controlled oscillator 2 is exactly the same. However, there's a couple of bolt-on circuits that are different between the two of them. VCO1 has the diode function generator. This takes a triangle wave and via this diode ladder that I mentioned, it saturates it into a sine wave output. John in the Titan synthesizer has labeled this as DFG on the patch panel. It also takes a triangle wave and makes a mark space output. The mark space is a definition that was used in teletypes and stuff for talking about the breaks between the signals. But in this, it's describing pulse width modulation. So this is basically a pulse width adjustable square wave output. On the design specifications in the magazine, VCO2 doesn't have these. It's slightly different. VCO2 is designed with larger capacitors in the integrator circuit, which means that it can reach a lower frequency. So the second VCO can either be a buzzy oscillator, you know, or a low frequency oscillator by selecting the larger capacitors. And instead of VCO1's diode function generator, it has a ramp function generator. What that does is it takes the triangle wave input and the square wave input and it gives out a ramp output, a sawtooth wave. And John has labelled this as RFG on the patch panel. Anyway, let's get back to it. Then we jump over to September 1973 to start building some more items. This is when John would have been introduced to the third oscillator, which actually has a waveform shaper, which is pretty much a really fast sequencer. You can use it as a sequencer to sequence the other oscillators, but you can also use it to shape your own waveform. It's a 6-step sequencer that is based at the bottom of there. You see step amplitude, those are the 6 steps, and this is the circuit right there. Let's stop again because I think we should have a closer look at this with the help of the oscilloscope. Now for the time of early DIY magazine synthesizers. This is quite a novel addition to a synthesizer. It's basically an audio rate sequencer. That means you can make it go fast enough to hear the sequence as a waveform itself. You can get exactly the same effect by using a very famous beginner DIY synthesizer project called a Baby 8-step sequencer. If you trigger one of those with a very, very fast clock, you can do exactly the same as this. What you're hearing right here is the pulse coming from VCO3. That clock is automatically pulsing the sequencer. Let's plug the sequencer output in. We've sped it up to the point that the sequencer is running at audio rate. This means we can program our own waveform in by adjusting the sequence on the sequencer. First off, if you adjust the amount of steps on the sequencer, you can adjust the interval that the note is running at. This is 1 step, 2 steps, 3 steps, 4 steps, 5 steps, 6, 5, 4, 3, 2, 1. So this is 1 step. There is obviously no noise because there's only 1 step, which means there's no push and pull on the speaker. Let's turn it to 2 steps. If we get the steps exactly the same, it'll actually be nothing. No matter where these steps are, if they're the same, it will not make noise because it's not pushing the speaker backwards and forwards with the electricity. If we turn up step 2, and turn down step 1. Let's get another step in. Now it's 3 steps. 4 steps. Now you turn them all down, it doesn't do anything. Let's go to 5 steps. Finally, 6 steps. You can think of using a step sequencer like this as a very, very, very low resolution digital to analog converter, because if you draw in the vague remnants of something like a triangle wave, it will sound sort of like a triangle wave. That's because it sort of is a low resolution triangle wave. Let's try it. So let's turn up number 3. Turn number 2 like that, number 1 a bit closer, number 4 bring it up, number 5 bring it up, and then we can simply turn it into a square wave by turning up 3, turning up 4, turning down 5, and turning down 1 and 6. And then bring it back to a triangle wave, turn up 5, turn up 1, and so on. Of course, there's an array of synthesizer and synth modules that do things like this nowadays, and there were at the time. But in a DIY purpose-built synthesizer, it's quite a novel thing. Anyway, let's get back to it.
There is also a voltage controlled amplifier. There is 2 in this synthesizer. Remember, John etched his own circuits because there was no strip board or circuit layouts in this very early magazine synthesizer. There is also the filter, which John did not tackle until 2022, and that is on a strip board on the back. Check the Q factor knob. That is the resonance, and that is the strip board for the filter back there. In this issue, there is also 2 mixer designs. One of them has knobs on the front, and then the other one, the DC mixer, is only available on the patch bay. There is also a spring reverb module, but this is not connected. We're going to connect that in a little bit to a reverb tank. Lovely jubbly. There's also a schematic for an exponential converter. There's 2 of those. Anyway, we're jumping over to the final issue because there's only 3 of them, and we get over to part 3. And this is squeezing a lot of them into a single issue. This starts with the waveform generator. This is an envelope generator in modern spiel. It's got a gen duration, attack, decay, there's a manual trigger switch, and yeah, it just acts as an envelope generator. This is the busiest noise circuit I think I've seen in a synthesizer. It's got a band pass filter, it's got a very low frequency output, which I think is based on a comparator, and John only tackled this recently, and it is on the strip board on the side. It is a very busy one indeed. We've also got got the joystick controller, which you fashion out of some aluminium plates, as well as some potentiometers that is on the side. There's also the etched circuit board, and you can see how it was put together right there. And if you didn't have enough this month, you could put together the keyboard controller as well. The schematic is there, and at the end there is the power supply. Funnily enough, the power supply is at the end of the issue. I guess it was assumed that the people who made this already had a bench power supply that would do the job beforehand, or you'd be a bit stumped. That's a shot of the patch panel. You can see all of the ins and the outs. The inputs are white, the outputs are green. Yeah, there's all of it right there. Have a closer little gander, and as you can see from the back, it is a little bit tough to diagnose this one because wires are somewhat going all over the place, but it's not impossible. But it's got a lovely patina to the panel as well. It's like aged to perfection.
So last week I finally got it out of the store cupboard again to tackle it, and I remembered that it did make a pretty good smoke machine. As you can see, upon further inspection, it turned out to be the rectifier in the power supply circuit. The power supply had given up, which had ended up causing the rectifier to burn out. So the first thing I did was to kill two birds with one stone by replacing the power supply. This fixed the problem, and at the same time, because it was a wall wart power supply, it was a bit safer. One thing I did realise is the actual main switch, which is over here, is just below the joystick hole. So there was nothing stopping someone like a kid popping their hand in and maybe getting electrocuted. I did think about covering this over, but I haven't found a good solution yet. It looks cool. It looks cool. So after replacing the power supply with a frequency central one I had sitting around that had 15-volt regulators on it, it meant that we could get it up and running again and see what worked and what didn't work. The next thing I did was completely go through the synthesizer, testing everything and writing things down that didn't quite work. I started by tackling the easy things, like a few of the potentiometers. When you twist them, they acted backwards. For instance, the Q control on the filter, the attack and the decay. All you have to do, if that's a problem, is basically swap the two outside wires on the potentiometer around, and that basically swaps around the way the knob works. After that, it was time to tackle the second oscillator. It turned out that when the power supply went, it likely took some of the components with it inside the second oscillator. It took me quite a few evenings to figure out what the problem was. I started by testing all the voltages, of course, all of the wires going to it to make sure it was all right. Then I swapped the operational amplifiers, the chips and stuff to see if it would start working again. I tested the capacitors. I tested all of the resistors against the first oscillator because they're both the same. So if there's any abnormalities, then it would be obvious if you're testing both of them next to each other. After testing nearly every single connection and every component, replacements for the transistors finally turned up. I replaced them all and suddenly it came to life. So it's obvious that one of the transistors that were directly connected to, I think it was the negative voltage line power supply, probably failed when the power supply went boo-boo. As you know, there was no reverb tank in it, so I put one of those in, I bolted it back together. So now I guess it's time to patch it up and make some funny noises. So now we have both of the oscillators working again. We can plug the output of one into the input of another, of course, to frequency modulate it. So let's turn it up. Then let's plug that through the filter. Let's get the square wave output of oscillator number 2 and going into the VA of the VCF. Let's try that. The filter, much like a few other things, might not be fully calibrated correctly, but I don't think that's a bad thing because it makes it sound different to other synthesizers. Oh, there's an offset on this one. And then we'll get the voltage control and sequence that with the sequencer. Let's get the output of the joystick and plug that into the voltage control input of the sequencer. Get another thing plugged into the joystick. Let's see if we've got the spring reverb working yet. We'll plug the input into one of the oscillators. Oh no, did I not plug it in? You plonker, you forgot to plug the spring reverb in. What an idiot. What an absolute idiot. There we go. Interestingly enough, the reverb is giving off a resonant kind of frequency that's an octave above it. That's pretty cool. For this one, you need to wire up the keyboard in a modular way for it to even work sort of like a keyboard. And then, yeah, you're not going to have much luck getting it super musical. So the keyboard has a pulse and a voltage out. The keyboard pulse has to plug into pulse, the sample and hold, and then it also needs to trigger the waveform generator, which is the envelope generator. But then we get the voltage control and we plug the input of the voltage control into the input of the sample and hold. Because if we don't plug the output of a keyboard into a sample and hold to sample the voltage coming from the keyboard, it won't hold the notes like a keyboard would. So the keyboard doesn't actually have a sample and hold inside of it like other keyboards do. You have to patch it in. Let's remove the output from the spring reverb and plug it through a voltage controlled amplifier, using the voltage controlled amplifier as basically a remote control volume knob. We're going to plug the output of the voltage controlled amplifier back into the reverb. We're going to get the output of the waveform generator, the envelope generator, plug it into the voltage control of the voltage controlled amplifier. Actually, let's plug it through an exponential converter. I call this Randy Wales in space. So of course, like the Practical Electronics PE synthesizer, it is best suited for making interesting sound effects and stuff like that. It has, funnily enough, quite a bit in common with the EMS VCS3. The technological forks in synthesizers were a little bit different in the America and the UK, so it's understandable that this is a bit more like an EMS VCS3 kind of thing than a Moog. We're going to be covering another DIY synthesizer of the era in the next video, and then at some point we're going to plug them all together and see what it sounds like. But this weekend I've had this set up at This Museum's Not Obsolete for people to try out, and it will be set up there from now on, so if you want to try it, come down to This Museum's Not Obsolete. I've included a bunch of samples and sounds that you can download and use at your own peril over on my Patreon, which needless to say supports these videos, the museum and everything else, and you get to see a bunch of other videos. Anyway, I'm Look Mum No Computer. This is the Titan synthesizer. If you like what you see, don't forget to subscribe and don't be scared to try it. Don't be scared to try it.